question says, to solve the system by the method of your choice. Our choices are substitution or that addition multiplication method. What would you pick for this first one? Why would we pick substitution? What makes it easier in this one? You already have an equation solved for x, yes. Okay, so if we do a substitution, we are going to take this expression and dump it in for that x, correct? So we would have 2 times the new expression, minus 18y equals negative 12. My expression was 9y minus 6. Okay, so I've done a substitution, and now I'm going to simplify. Distributing, I've got 18y minus 12 minus 18y equals negative 12. If I combine like terms, the y's drop out. I'm left with negative 12 equaling negative 12. Okay? When your variables completely disappear, you have to analyze the rest of what you have. Is it true or false? So in this case, negative 12 does equal negative 12. True statement, which means what? Now, I'm going to have you write infinitely many solutions such that, and then I need you to give me one of the equations. I don't care which one you give me. I'll use the first one, such that x equals 9y minus 6. What that does is it tells everyone that we understand not every ordered pair that I could make up is going to work. Only the ones that work in that equation will also work in the other equation.
That's what all real numbers is that?
All real numbers is not quite accurate, because all real numbers imply that I can make up any ordered pair and it's going to work. Does that make sense? It's not that every ordered pair works. What we're saying is that every ordered pair that works in the first one is also going to work in the second, right? It's just the same line written in 2 different forms. So you do have a limited number of solutions in that they have to fit on the line. Does that make sense? Okay. Looking at our second one, it does say to solve using that addition method. Now, the term addition method means at some point we're going to be adding the equations together. We may need to do a multiplication before we can get to that step. Okay? So, can we simply add the 2 equations and have one of our variables drop out? Okay, so if we have to do multiplication, do we want to get rid of x's or y's? X's look a little easier. We could simply multiply the first equation by what? All right, multiplying up here, we've got negative 5x minus 10y equals 25. Combining it with the second one, our x's will drop out when we add those together. We end up with negative 7y equaling 28. Dividing, we have y being negative 4. Then what do we have to do? Plug it back in. Does it matter which equation I plug it back into? No? Okay. So if I plug it back into the first one, I'm saying x 2 times negative 4 would be negative 8 equals negative 5. Adding the 8 over, I get a 3. So I'm going to put the answer down as 3, negative 4. It's an ordered pair. X is first, y is second. If this was a test question, I wouldn't stop there. I would check my answer. It takes about 10 seconds to do, but it's going to help you catch mistakes before you turn in your test. So I plugged it back in the top equation to figure out what x was. Now I'm going to try it in the second equation just to verify. So I'm going to put a 3 in for x, and I'm going to put a negative 4 in for y. So 5 times 3 would be 15. 3 times negative 4 is negative 12. I'm supposed to get 3, and I do. So I've verified that it worked. That's my answer. Questions on either of those? Okay. Our next example also says to solve using the addition method. I cannot simply add the 2 together and have anything drop out. So I am going to have to do some multiplying first. Do you want to get rid of x's or y's? It doesn't matter. We have to do 2 multiplications either way. But let's say we get rid of x's. we need to make those x's, the coefficients, be a 10 and a negative 10. All right, so multiply the first one by 2. The bottom one then would need a negative 5. Could I have also used a negative 2 on the top one and a positive 5 on the bottom? Yeah, either way will work. So distributing, we've got 10x minus 8y equals 54. Second equation, negative 10x minus 25y equals 45. Adding those together, I'm going to end up with the x's dropping out. I end up with negative 33y equaling 99. When I divide, y would be negative 3. Okay. Plugging negative 3 back in, I can use either equation. I'll plug it in the top one. That leaves me 5x plus 12 equals 27. Subtract the 12 over and divide. So ordered pair answer would be 3, negative 3. Again, I used the top equation to figure out that x was 3, so now I'm going to check it in the bottom equation. I'm going to put a 3 in for x and a negative 3 for y. That leaves me 6 minus 15 is negative 9. That's true, so I know it works. Okay. Our next example, we are shifting to 3 equations and 3 variables. These are the harder ones. I'm going to be requiring that you show me what equations you're combining and how you're doing that. Okay? If you want any kind of partial credit on this question from the test, you have to tell me what it is you were attempting, because there's different routes I can go to get my solutions. And I'm not going to try to figure out which route you chose to take if you don't help me with a path. Okay? So, what I would expect to see. Analyze your variables. If I look at all my x's, I don't have a single x that I can use to help cancel the other ones. It would require multiplying quite a few times, right, to get my x's to disappear. Then I look at my y's. The y's are going to be a little easier. Why? I have a 3 and a negative 3 already. So I have 2 equations, the first and third one, where if I add those together, already my y's are going to drop out. I don't have to do any multiplying. Okay? Looking at the z's, I'm back to the same thing I had with x's, right? I don't have any singletons. I don't have any opposites. It's going to require a little more work. So I'm going to choose to get rid of the y's. Okay? So I'm indicating which variable I want to eliminate. And then you're going to tell me how you're connecting the equations, how you're combining them. I want to use equation 1 and add it to equation 3. Okay? If I add those 2 equations together, I end up with 9x's, the y's drop out, I end up with a negative z, and adding my constants, I get a negative 13. Okay? I would recommend circling that equation. You're going to need it in a few minutes. Okay? But we're going to put it on hold for a sec while we get the other equation figured in. As soon as I have picked the 2 equations I just used, I now have to use the one I haven't used yet. Okay? So I've already dealt with equations 1 and 3. I have to now start with equation 2 and do something with it. Okay? I can pair it with either equation 1 or 2. That part doesn't matter. But I have to get equation 2 in there. So let's say we combine equation 1 with an equation 2. Okay? I can't simply add them together. The y's aren't going to drop out. So I'm going to have to do some multiplication. If I'm trying to get these y's to disappear, I need a 15 and a negative 15. Does that make sense? Okay, so the top equation I'm going to multiply by a 5. So 5 times equation 1. The second equation I'm going to multiply by a 3. We good with that? So that's the little notation that I want to see on your paper so I can tell what it is you were trying. 5 times the first equation gets me 25x plus 15y minus 25z equaling 30. 3 times the second equation would be 6x minus 15y plus 6z equaling 3. All right, combining these, we end up with 31x. The y's disappear. We've got negative 19z and a 33. Okay, that is the second equation that I've created where I have just two variables. So now I want to put these two together and create a system from those. Does that make sense? Okay, so picture combining the two that I have circled in yellow. Which variable would you want to try to get rid of? Z is a little easier. I could just do one multiplication. What would I have to multiply this one by? I'd need a negative 19, right? To make that a positive 19, which would cancel with the other one. So we're going to take negative 19 times 9. What do we get? Sorry. Negative 19 times 9. Okay, whoops, negative 171. Negative 19 times negative z is positive 19z. And negative 19 times negative 13 should be 247. Okay, so now, can I add these together? Okay, the z's are going to drop out. I end up with negative 140x equaling 280. So x is going to be negative 2. Okay? Once I know my first variable, I can plug it back in, substitute it back in, and find the other one. Okay? I'm going to substitute that x back into that equation. It looks like it's the easier of the two. 9 times negative 2 would be negative 18. Minus z equals negative 13. Adding 18 over, I've got negative z equaling 5, and then dividing out my negative, I've got a negative 5. Okay? Now I know what x and z are. I can dump those both back into one of my original equations to find y. Okay? All three of the original equations look about the same in terms of difficulty level, so we'll just go ahead and use the first one. The first one says 5 times x plus 3 times y minus 5 times z equals 6. We're trying to find that y, and we know that x is negative 2 and z is negative 5. So combining, we've got negative 10 plus 3y plus 25 equals 6. Negative 10 plus 25 would be 15. If I subtract the 15 to the other side, I end up with negative 9. So y must be negative 3. All right, ordered triple. X is negative 2, y is negative 3, z is negative 5. Again, if this is a test question, would I take those back and plug them into the other two equations that I haven't tried yet? Okay? All right. The next couple that we have are a little more difficult because they're nonlinear, or at least parts of them are. Okay? Nonlinear, meaning we're talking about quadratics, maybe it's a parabola, maybe we have a circle equation, things like that, okay, where we've got some x squareds or y squareds. For the first one, x squared plus y squared equals 34. That is a circle. All right? The bottom equation, x minus y equaling 2, that is a line. So we are talking about a circle and a line intersecting. I have several options. I could have a circle and a line that don't cross at all. I could have a circle where the line crosses just at one spot, or I could have a circle where the line goes through and I cross in 2 spots. Okay, those are my options. I could get no solution, 1 solution, or 2 solutions. When we go to solve this, the directions say to use a substitution method. Easiest option is to take your linear equation and solve for an x or y. Then we can dump it into the more complicated one. So let's say we solve for this x. We'd have to add the y to the other side. And I'm going to take that now and substitute it in for my x. Okay? So I'm going to have y plus 2 squared plus y squared equals 34. When you square a binomial, like y plus 2, you have to remember the formula that creates the trinomial answer, or you have to write it out twice and FOIL it. But you will get a trinomial. You don't simply square the y and square the 2. Okay? So y plus 2 times y plus 2 gets me what? Y squared plus 4y plus 4. I still have the other y squared and it equals 34. Because I have some squared variables, I'm going to move everything to one side and use factoring to solve it. So combining my y squareds, I have 2 of them. I have a positive 4y. Subtracting the 34 over gives me negative 30. To make the factoring a little easier on this, I'm going to divide out a 2. And then how does that trinomial factor? All right, y plus 5, y minus 3. So my possible y values are, okay. Then I have to go and plug those back in, okay? My easiest equation to plug them back into would be that one. That's the equation for a line. Your line is more restrictive than your circle, okay? If I were to plug these 2 y's back in here, when I go to solve for this x, I'm going to have to square root. I'd get plus minus. I'm actually going to create answers that don't work in the other equation, which is why I keep emphasizing make sure you check your answers in both equations. Okay? You avoid that by putting them back into this linear one. Go ahead and substitute a negative 5 in for y, and we get negative 3. And if we substitute a 3 in, we get 5. So the 2 places that it intersects are the points 5, 3 and negative 3, negative 5. Okay? Looking at our next one. X squared plus y squared equals 85. X squared minus y squared equals negative 13. We can simply add these together, right? Our y's are going to drop out. We've got 2x squared equaling 72. Dividing out the 2, I've got x squared being 36, and then when I square root, I get, good, remember the plus minus. So I have to plug in a 6 and I have to plug in a negative 6. But look at what happens when I dump them in. I'm going to square it, right? It's going to turn into 36 either way. So I'm going to dump them both in at the same time. Okay? 36 plus y squared equals 85. Subtracting my 36 over gets me 49. So I end up with y being positive and negative 7. Okay? That means when I plugged in a positive 6 for x, I got a 7 and I got a negative 7 out for y. 2 answers there. When I put a negative 6 in for x, I also got a 7 and a negative 7 out. So this is one where there are 4 solutions. And again, you could plug them back into the other equation, make sure they work. All right. Our last one that we're going to look at today, we are graphing a system of inequalities. The first one, x plus 5y is less than or equal to 10. That is in standard form. So I'm going to go ahead and make a t-chart and find my intercepts. Plugging a 0 in for y, we get 10. Plugging a 0 in for x, we get 2. So I know I'm hitting here at 10 for x, 2 for y. Will it be solid or dotted? All right, so we've got a solid line going through there. Shading. Does the origin work in that equation or in that inequality? So I'm shading towards the origin. Okay. Second one is already in slope-intercept form. So I'm going to start with a -7 intercept, and I have a slope that is +1. So up 1 over 1. Okay. Solid or dotted line? Solid. Does the origin work? Yes? So I'm shading towards the origin. So the overlapping section would be all of this stuff. Okay? And it would include the solid lines that border that. Okay? Any points on those parts of the lines would also work. All right, so for homework, all right, so work on that over the weekend. I will get you guys some graph paper.